So I had this other idea where just like right now, literally like 1 second before I just hit the start recording button, I had this idea that made that one thing that I kind of, so why, like, why does the objective function need to actually include the whole forward pass? Because I guess that's what you use to calculate the y pred and y true, right? But I guess I guess that's kind of the thing, right? Because as you can see, softmax in a way yeah, softmax, yeah, but that's what it is, right? I mean, it has to be done like that, unless this is somehow done differently. I don't know. Let's see if I can go back to that example. Autograd, github.com. Autograd. Simple neural network. So here the prediction does a forward pass, which essentially implements a deep neural network. The parameters are a list of weights and biases. So input is an n times d matrix, and so it basically, for weights and biases, it calculates these inputs. It calculates, and then it returns a log sum exponential or whatever. Now, you get the training parameters, you do random initialization. You see the objective function as it takes the parameters and it's log posterior of these parameters, train images, train labels. I guess this is the real distribution stuff, I guess, yeah. Parameters. It takes log posterior. Yeah, okay, and log posterior actually does do the no-net predict. So it does use these inputs and targets. Train images, train labels. It even uses stuff that is like defined in here. Objective and parameters. So this is kind of designed, but that's just a matter of design. But no, yeah, it actually contains the whole thing. It also contains the logic of the forward pass. Now note that this forward pass doesn't have a softmax, and actually what we did last time is when we checked without the softmax, it actually worked really well. So why are we even using softmax to get probabilities? That's also bullshit, I think, because softmax. No, it's okay. It's got between 0 and 1. What our network does, it takes the logits and it turns them into probabilities. Now, how to make autograph work with with objective functions with softmax? Objective functions with softmax and autograph. And can we ask the AI here? How can I invite no AI? How can I get the functions to work well with each other? The cross entropy. Predicted probabilities, yeah, but the predicted probabilities is something you're giving it already. That's not what we're doing. And it just doesn't get it. The fucking AI doesn't really get it, so. Yeah. However, Green says some functions are complex and involve computing the Jacobian matrix, which are expensive, but tensors. Really? Yeah. Softmax. But what's happening here is the softmax function essentially is fucking up with my optimization with the derivative. Why is that? Softmax. Is that because it's calling a function and not doing these? What if I guess that doesn't really matter, right? I can call other functions that just should be the same. Should be really the same. So give me a second. No, that's stupid. That's stupid. When I use softmax, so softmax in my objective function, if almost evaluates to 0. Why is that? Is that the function that has this NP max for numerical stability in here? Yeah, I mean, takes the vector, converts into probability distribution, 0 and 1. Hasn't understand how changes in percent affect the training. Issue with derivative evaluation, checking the objective function. Greater than the objective function, like a loss, often includes the derivative of the softmax. When facing cross entropy loss, is conditioned with softmax. The derivative simplifies nicely and often evaluates to certain predictable patterns of values. The output can be very small, very large, leading to numerical instability or certain repeated values in the gradient. That's correct. Numerical instability, log sum exp trick. What is the log sum x trick? Is this? To improve stability. It's just because log sum exp. But is this something you use instead of stable softmax? Yeah. But that's already how we implemented it, I think, right? So if I do this, I think that's still gonna lead to a flat thing. I think it's the same, right? It's taking the max and P max. It's doing Z minus Z max. Yeah, and then it's doing the sum. Okay, here add something like axis minus 1, whatever. It's essentially the same. I don't know why these things skip dimensions, whatever, if this make a difference. I mean, if it will make a difference, I would just get peace, because I just don't understand why that will make a difference, to be honest. But let's see what happens. I guess we have to open the output tab. And then we've only got 3 epochs, but it's gotta see it in here. It's gotta be something with a softmax, and the stability of these. and maybe either these, either initialization stuff, right? There's nothing here interesting. Trying perplexity and then try Google. See if it leads to anything interesting. Fucking flat. It's the same. That's exactly the same implementation. Just makes no sense. I'm just increasingly convinced is the stability of these now. An interesting idea would be to do these and then basically give me a script that takes stable softmax, gets the derivative, and plots a few values. So if I do a new file and I do tests off, but I import autograph. So I take this stuff and then I take this, but I take this guy instead, and then softmax derivative. That's just basically the derivative of these, and this is just the stable softmax. Is this guy here. Well, we need also these. Okay. So does this work? I think so. Shell Python tests soft pie. Huh? What? No. Fix these. AI. Here's the whole thing fixed. Okay. Whatever. Whatever next time. I can't really make it now. It's not gonna work well. No, I don't have time now, but okay, I'll explore these. It's gotta be something that I can do with testing. And it's gotta be softmax.